is the IP address of the device. For this IP address device, I need to have a logical address. So it will send the request. So now after receiving the request, what the receiver will do? So receiver will get to know that, okay, this is the transmitter who wants to transmit the data, means he wants to have a link between us. So I should transmit the link address, or the through the link in which you can transmit the data. So he will be specifying the link that I am attaching to you with this link, so you can transmit the link, your data with this link. So he will be transmitting the link address to the corresponding. Since the receiver is should know, or the receiver should acknowledge the transmitter, the remaining nodes no need to acknowledge that B is connected to A with this link. So the receiver will not broadcast its reply. It will only reply only to the transmitter, that is a node A. So therefore he will give a reply only to node A, saying that this is the link address of mine. So you can see here, the in the reply you can see I am the node and my link address, means link layer address is L2. So with this reply, the system A or a node A will get to know that what is the logical addresses of the system. So this will be done in a network layer, and that will be done, we are going to call it as a address resolution protocol. So this address resolution protocol, it is responsible. Okay, so now what it is doing is, so it will have an acknowledgement. So based upon the acknowledgement, the receiver, the transmitter will get to know that what is the logical address of the system B. So through this logical address, the data will be transmitted. So in order to have that, so we have one data layer packet format. So you can see here the header type, protocol type, hardware length, protocol length, and operation. So whether which operations we are doing. So are we doing the means reply operation, or we are sending an request operation. Okay, along with that, what is the source address of the hardware, destination address of the hardware. So all those details are there in the packet format. Okay, so now you can see here the previous case what we have taken the example. So for that only, how actually the address format or the frame format of the ARP request and ARP reply will be having. So you can see here ARP request, in that so these, the top one means the logic, means the hardware prototype, all those things we will talk in later in another subsequent chapter. But you concentrate on, you can see here in the ARP request format, you can see here. So what we are having is here L1 is a link of the system A, and N1 is the IP address of the system A. Now he don't know what is the link address of the system B, but he know the IP address of system B. So therefore what it is doing, in a link address he is specifying all zeros, because he don't know what is a system logical link address of the system B. Therefore in ARP request it is giving all zeros in the receiver link address, followed by the IP address. So what is the IP address? The IP address is 2. So now you can see here, since we need to broadcast the device, or we need to broadcast this ARP request to all the neighbors which are connected to me. So therefore I am framing the frame. So you can see here multi-frame I am creating. So what is that? Data followed by the source address followed by the destination address. So this will reach to from A to B. So this frame will go to A to B. So from A to B, now B will be receiving this frame. So after receiving this frame, so what he will be get to know that, okay, the system A wants to have a link between us, and he wants to know what is the logical address of the links between A and B. So what he has to do, he has to provide the link address of its associativity. So therefore you can see here in the ARP reply, L2 is the link of me which is connected to you, and N2 is my IP address, and where exactly this has to go, the receiver is now the system A, transmitter is system B now in this case, and receiver is system A. So therefore in a system, what is the link it is having? The link is L1 for it, and what is the IP address? The IP address is N1. Okay, so with this it will frame the packet. So actually here it is wrong, mistake is there. L1 and N1 it has to be in a ARP reply, but they have given it as N2. Okay, so now what I said, as I said, the system B should only respond to system A. Why? Because this is the receiver who is responsible to have the link, and that address the receiver, the transmitter is requesting. So therefore, the system B has to respond only to system A, irrespective of the remaining devices which are there, which are connected to that switch. Okay, so therefore, the system B will give only a unicast frame. Only it will give a unicast frame, so that it will reach only particular to the node A. Okay, so therefore you can see here data is there. Now the source is the system B and the destination is the system A. So he will transmit the data, and so that the system A will receive the data. Is that okay? Next, so the same thing. So how exactly the networking layer will act? How exactly the networking layer act? Exactly the logical link layer will be created. So for that we have taken one example. So one example what we have taken is, we have taken an internet example. So where we have one transmitter called as a Alice, and we have one receiver called as a Bob side. So the Alice want to transmit the data to the Bob side. So how they have connected? They have connected with the two router switches. That is, R1 is connected to the transmitter Alice, and the receiver is Bob is connected to another link, that is R2. Whereas there is a link between R1 and R2, that is a point-to-point link is there between R1 and R2. So what the Alice will do is, the Alice will connect to router switch R1, it will transmit the data to router 1, and the router 1 will transmit the data to router 2, and the router 2 will transmit the data to the bomb. So how exactly the data, or how the Alice will get to know that the logical address of R1, and how the R1 will get to know that the logical address of R2, and how the R2 will get to know the logical address of Bob, and how exactly the Bob will receive the data, we will be knowing through the use of layering architecture. So you can see here, so what are the activities will be done at the Alice site. So you can see initially Alice will be having the link which is connected to, means the link where how we can connect is through the link LA, and the IP address of the Alice is NA. NA is nothing but the IP address, and LA is nothing but the link address, so that he can connect to any switch. Okay, so now he don't know where how means what through which link it has to connect to router 1. He don't know through which link it has to connect to router 1. Okay, so for that what he will be doing is, he will be using an ARP protocol. So what he will be doing is, he will be transmitting his forwarding. You can see here the forwarding table. So in the forwarding table, the Alice will transmit the his address. That is the network means he will be transmitting the IP address N1. So for that N1 IP address, I want to have a logical link address for that. So ARP request means reply. What you will be getting? You will be getting a reply is equal to L1. So means what? The Alice can communicate through the link called as L1. So through the ARP request, it will get to know that from the network, means in the network layer of the Alice side, we will be get to know that. And the network layer will receive the data. So from where it will receive the data? From the transport layer, it will receive the data. Okay, so from the transport layer, in the network layer of the Alice side, it will receive the data, and it will add the IP addresses of it. Okay, so it will add the IP addresses of it. So what are the IP addresses? The transmitter IP address is NA, whereas the receiver IP address is NB. So you can see here, as I told you, network layer is responsible for host to host communication, or it is responsible for node to node communication. So what is the node IP address? The node IP address is NA, whereas the node receiver IP address is NB. So therefore, in the network layer, the whatever the data we are going to receive from the transport layer, along with that, I will be attaching the source IP address and the destination IP address. So the source IP address is NA, and the destination IP address is NB. So NA, NB followed by the network layer. So this we are going to call it as a datagram. Okay, means what? Whatever the data we have received from the network layer, we are going to call it as a datagram in the data link layer. So this datagram will become a data for the data link layer. Okay, so I told you, right, network layer, whatever the data which is associated with network layer, we are going to call it as a datagram. Okay, so you can see here the datagram. What is a combination of this datagram? Datagram is nothing but it is a combination of source IP address, destination IP address, and the data which is received from the transport layer. So now for this data, so the network layer, what it has to do, it has to transmit the between the two links. So what are the link? The transmitter link is LA and the receiver. So the data has to reach to the router one. So which through which link? L1. Okay, so that has been got from the ARP protocol in the network layer of the Alice side. So therefore, it will generate the frame. So you can see here in the frame, we have a data which is taken, that is a datagram. Along with datagram, I need to have a logical addresses of the source and destination. So the logical address of the source Alice site is LA, that is L1, and the destination address of the router 1, it is nothing but LA. Okay, so therefore it is attaching, means L1 and L2 the logical addresses from the link. Okay, so this data or this frame will be given to physical layer, and this physical layer, it will convert the frame into bits values, that is the signals will be converting, and this signal will reaches to the router 1. Okay, now how router 1 will react to it. Okay, so now you can see here the physical layer of the router 1, it will receive the signal from the Alice. So now this physical layer, what it does, it converts the signals into frames, or it will convert the signals into stream of bits. So what we are going to call, we are going to call it as a frames. So now in the frame it will see, so who is the transmitter? Transmitter is the Alice side with a logical address LA. Now who is the receiver? Receiver L1. Whether L1 is belongs to me, it will check in the data link layer. Yes, L1 is belongs to me. Okay. So now what it does is, it will remove the logical address. It will forward the datagram to the next layer. So what is the next layer? The next layer is a network layer. In the network layer, it will see router, whether the data is belongs to me. How? He will check the IP address of the destination. So the IP address of the destination is NB. If the data is particularly belong to R1 means, then it would have been N1. Here it is NB. NB means destination. So destination is not here. Means R1 is not the destination. The IP address of the router is N1. But whereas in the packet, the destination address is NB. So it come to know that, okay, N1 means this IP or this data is not belongs to me. So what I should do is, I should forward the data. So how it should forward the data? It has to find the link, right? So in the network layer of the router 1, it will follow the ARP protocol. So through the ARP protocol, it will get to know that I should forward the data to the router 2 with a link called as L3. Okay, so now what it does is, it will do some modifications in the data link layer. So what modifications in the data link layer it will does is, it will take the same datagram what it has been received, but it will change the logical addresses. Now the sender is the router 1 and the receiver is the router 3. So it will add the destination address, that is L3, it will add transmitter address L2, it will add, along with that it will add the datagram. Okay, so that will be converted into again in physical layer. So that signal will reaches to the next, where it will be reaches, it will reaches to the router 2. Now router 2, again it will do the same process. It will see where, what is the logical addresses of the destination. Yes, logical address of the destination is mine. So means the data belongs to me. Next, that data will go to the network layer. In the network layer, it will see, okay, whether data is belongs to me by checking the destination IP address. What is the destination IP address? NB. Whereas my IP address is N4. Okay, so what it does is, okay, so the data is not belongs to me, so I should route the packet. Okay, so therefore what it does is, it has to receive the logical address of the bob which has been connected to the router. So through the use of ARP protocol, it will do the ARP protocol execution, and it will get to know that the link is LB. So again it will do the framing of the packet. So how? It will take the datagram, it will add this logical address, and it will add the bob logical address, and it will make the frame, and that frame will be given to physical layer, and that will be converted into signal. Now the signal will reaches to the bob side. So in the bob side SWOT, the physical layer will receive the data, and it will check whether the logical address is belongs to me. Yes, the data is belongs to me. So it will remove the logical address from the frame. it will datagram will be given to network layer. So in the network layer, what it does, it will see whether the destination address is belongs to me, means it will compare the IP address of it with respect to the destination address what it is there. So the destination IP address of the receiver is B, whereas the destination IP address in the datagram it is B. So means what, the packet is belongs to me. So it will do the decapsulation. So means what, it remove the NA and NB and it will forward the packet to the transport layer. So this is how the data will be forwarded from layer by layer mechanism. So from each router it will be forwarded. How exactly this data link layer will be acting upon? So I told you, right, the data link layer is it is subdivided into two sub layer. What are those? One is called as a data link control layer and one more is called as a MAC layer. Okay, so what are the services that the data link control layer will does is, so you can see here it will does the framing, flow and error control. So the data link layer will does three operations, that is the data link control layer. It is also called as a LLC layer. In sometimes the data link control layer, it is also called as a LLC layer. LLC means logical link control. Okay, so this layer it is responsible for framing the packet, to do the flow control and to do the error control. So all these functionalities will be done in the upper part of a data link layer. So what is that sub layer? The sub layer is data link control layer. Then what does the MAC layer will do? MAC layer, it is also called as a multiple access control. So this MAC layer, it is responsible for sensing the channel before transmitting the data. So if there is any transmitter is transmitting the data at any instant of time, means then if one more node wants to transmit the data, means then he has to sense the channel. What do you mean by sense? He has to see whether anybody is transmitting the data within the network. If someone is transmitting, means then I should wait. If I also transmit, means the data will be colliding mine and the one who is already transmitting. So the data will be lost and it will not reach to the destination. So means what? Simultaneously two members cannot transmit in a wireless channels. Means within a geographical boundary. So there are different techniques are there. We will see it in later cases. But as of now, two simultaneous transmission will leads to a collision of the data. So we should see that if anybody is transmitting the data before we start transmitting, so that we are going to call it as a carrier sensing. Okay, so we should sense the channel. If channel is free means then I should transmit the channel. If channel is busy means then I should wait for some time, and after some time again I should see whether the channel is free or not. If channel is free, then I should transmit the data. So that job will be done by the MAC layer, MAC sub layer, that is nothing but medium access control. So the detailed analysis of this MAC layer, one more chapter is there, so that we will do it in a module number 2. But as of now, you should remember is that the data link layer is being divided into two sub layer. One is called as a data link control layer. Upper layer is called as a data link control layer, and the lower layer we are going to call it as a MAC layer. What are the functionalities will be carried out by this data link layer is, first one, the data link control layer, that is upper layer will does three operations. What are those? One is it does a framing of the packet, it does the error control, and it does the flow control of the packet. Okay, so this is how you need to know, or these are the functionalities which has been carried out by the data link control. As I told you, MAC layer, it is responsible for sensing the channel. So if you remember this only for this data link control layer means, then it's enough. Is that clear?
Yes, sir.
Okay, shall we go next? Shall we go next?
Yes, sir.
Oh, so now, see why we should do the framing. That is the question. First question. See why we should do framing. Framing means what? Fragmenting the data. So if you have a large amount of data means I should fragment it and I should transmit the data. There are several advantages of fragmenting the data or segmenting the data. Can anybody tell me what are the uses of fragmenting the data? Yes, anyone? Yes, Bhargav. Venkat is here.
Yes, sir.
Yes, Venkat. Let's say I have 1 MB of data is there. 1 MB of data I don't want to transmit. What I want to do is I want to divide it into two blocks. I want to transmit. What are the advantages of segmenting the data and transmitting the data? Okay, so means what? The rate of transmission of my rate, if it is equal to rate of reception of the Shreya's rate, means it is means there is no any loss in the data. So if you remember, I gave an example. So let us assume that at any instant of time or at each instant of time, one ball I will be throwing to Shreya. So Shreya can hold it very properly without any missing it. If I transmit two simultaneous data simultaneously to Shreya, she might with difficulty she might hold. Okay, so at the same time, if I try to throw 5 to 6 balls simultaneously to Shreya, means she may not able to hold entire data. Okay, so why? Because the capacity of the Shreya is some limited is there. If I am transmitting more than that any instant of time, so you may feel that Shreya may not hold the entire balls. Okay, so means what? If the capacity with which you are transmitting, if it is less than the capacity with which the data is flowing over the network, if it is less means then we may have a data loss. So that is why the larger amount of data we cannot transmit over the channel. One thing. Next, okay, the capacity is also more. Means Shreya can hold 6 balls simultaneously. But the thing is, if there is any mismatch happens during the transmission, then the entire data will be affected. If there is any mismatch or if any error corrupted happens to that entire data means, then the entire data we need to retransmit once again. Okay, so other than this, what we can do is, so instead of transmitting the larger data, so I will divide them into segments or I will divide them into frame. Okay, so these frames I will transmitting over the logical links. If any one frame is affected means by the error means only that frame will be corrupted. Okay, whereas the remaining data will be original only the date frame which has been corrupted, that frame I need to transmit. So means what? The retransmission of data will be less in case of framing mechanism. Whereas if you transmit the whole data simultaneously means if any one bit error occur within that frame means then you need to transmit the entire frame irrespective whether they are correct or wrong, because there is one error is there, only one point of error you cannot rectify. So what you're supposed to do is you should transmit the entire data. So instead of that, what we do is we do the framing mechanism. In framing the mechanism, only limited number of data I will be taking and that I will be transmitting. So during the transmission, if any error occurs means then the error occurs only to that frame, whereas the remaining frame will not be affected. Okay, so for this mechanism, so we will be using a framing method. Okay, so now we will get back to this concept. Okay, so now there will be question. So what question? So what is the size we should fix for the framing? Okay, so means I said framing, right? So framing means what? Segmenting the data. So now there is a question. What type of framing I should consider? There are two types of framings are there. One is called as a variable framing size and one more is called as a fixed framing size. In fixed framing size, what we do is we fix the size of the frame some constant value. Okay, so means what? Whenever I want to frame the packet, so with the constant frame packet size, I will frame the packets or I will create the packet. So that is one type of framing mechanism. There is one more type of framing mechanisms. What we do is we go for a variable data size. So means what? One frame may consisting of 12 bytes and one more frame may consisting of 16 bytes. So means what? The data what I am transmitting, so it might be changing in case of variable frame size. Okay, so there are two types of frame size when you want to transmit the data over the data link control link sublayer. One is a fixed variable size and one more is called as a variable fixed frame size, one method, and one more method is variable frame size. But you should be very careful when you taken care of variable frame size. When you're taking care of variable frame size, why you should be very careful is because you should know where exactly the data is starting and where exactly the data is ending. Why? Because each frame you don't know what is the size of the data. One frame you made that it is 2 bytes. Okay, you received 2 bytes. The next time the data might be 3 byte because it is a variable frame size, you don't know. Okay, so therefore in variable frame size you should know where exactly the data is coming, what is the size of the data, and how you are identifying the start bit of the data and stop bit of the data. So for that, to identify the size of the data and to identify the starting of the frame and ending of the frame in variable framing size, we go for two important mechanism. That is, one is called as a character oriented approach and one more is called as a bit oriented approach. Okay, so in character oriented approach and in bit oriented approach, what we do is we use this character or a bit orientation pattern to specify the starting of the frame and ending of the frame. So with this characters or a bit oriented approach, we will get to know that what is the data or at what time the data is starting and at what time the data is ending within the frame. We will be get to know through the use of this character oriented approach and a bit oriented approach. Okay, so you can see here in character oriented approach, so you can see here variable number of datas are there. See, generally when we talk about data, we will be converting that data into 8 bytes. Okay, and we will be grouping the data into 8 bits, and this 8 bits we will be representing in terms of ASCII values. Okay, so that is why always we represent the data in terms of character only. So that's why it is called as a character oriented framing. Okay, so now you can see here the frame in a character oriented protocol, how it will be looking. So you can see here the data what we are going to receive from the network layer, that is called as a data from the upper layer. So it will be variable number of character will be having. So for that I should know, right, when is the starting frame and when is the ending frame. So for that what I will be doing is I will be attaching a header and trailer. Header and trailer is nothing but a source address and the destination address. Header and trailer is nothing but a source address and a destination address. But I should know where exactly the frame is starting. So in order to know where exactly the frame is starting and where exactly the frame is ending, we will be using a flag byte or we will be using a flag bit. It may be bit, it may be byte. In case of character oriented, it is an 8-bit data. In case of bit oriented, it will be 1 bit of data. So now you can see here at the beginning and the end of the frame, we are attaching the flag. So you can see here flag is present at the beginning of the frame and at the end of the frame. So whatever the data we will be receiving, so for that we will be attaching header and trailer. So header is a source address and trailer is a destination address. For that we will be attaching a flag bit. So this flag bit will indicate that okay, the starting frame of this is starting with the flag bit. So if I get to know that the flag bit first time, it is called as a start bit. If you get the flag at the second time means, then we can say that this is the end of the frame. So in this end of the frame, you should identify what is a header, what is a trailer, and you should eliminate and you should take the data. So this is how the character oriented framing will takes place. Okay, so now what happens is in the case of character oriented frames, okay, so if whatever the data we are transmitting in, is anybody any doubts, any doubts?
No, sir.
Okay.
No,
Hmm.
sir.
If data what you are transmitting, if it is also having a flag bit means, then that will be a confusion for the receiver. Okay, so why that will be a confusion for receiver? So if any flag bit it receives within the data means, then it will take it as the end of the frame and you may decode the given data in a non-uniform manner, or you may not decode the data correctly. Okay, so means you should try to identify what exactly it is by bit byte stuffing. If your data, whatever the data, see, we are creating the flag which is different from data. Okay, so means what? I will be using some character. Those character will not be included in the data. Okay, in that case, okay, you have attaching the initial flag, you are having the data and you are having the flag. Okay, so through the use of the unique character at the flag, we can get to know that which is data and which is flag. But sometimes what happens is within the data, so whatever the character you have used for the flag, if the same character is appearing in data also, there will be a confusion. So what is the confusion is whether it is a data or whether it is a flag, there will be a confusion. So in order to avoid this confusion, we go for one type of stuffing of characters within the data, that is nothing but byte character, that is a byte stuffing process we are going to call. Okay, so what do you mean by byte stuffing is if a flag bit is appearing in the data, so if that for that flag bit, what we will be doing is we will add one extra character saying that whatever the flag bit you are considering in the data, it is a data, it is not the flag. Okay, so in order to identify it is a data within the flag, so we are adding or we are putting one more extra character. What is that? A special character we are putting. So through the use of special character, you should consider the flag within the data, it is a data, not the flag. Okay, so that process we are going to call it as a byte stuffing. So you read it carefully. Byte stuffing is a process of adding one extra byte whenever there is a flag or a escape character in the text. Okay, so generally we will be using a escape character or a flag as an starter bit and enter bit of the frame. If the escape character itself, which if it is present in the data means, then we should identify or you should tell the receiver that it is not an delimiter or it is not the starting of the frame, it is a data itself you should mention. So in order to mention that, we will be using a character oriented byte stuffing. So in the character oriented byte stuffing, you can see here before flag or before the escape character, extra character, we are putting one more additional escape characters. So through the use of extra additional escape character at the receiver frame, what it does it will get to know that okay, the subsequent flag, it is not a flag exactly, it is a data actually. So it will retain. So means it will not remove this flag. Similarly, if you are getting an escape character in the data means it is not exactly the escape character, it is a data itself. So therefore it will remove one escape character whereas it will retain the another escape character.